hello for one last time.
This time for sure.
This time for sure, yes. So I have few questions that you guys were interested in terms of reviewing for the final exam and also the exam 3, which consists of linear systems, and it consists of eigen stuff. So let's start with compressing the two first order equations into a single second order, and then do the rest of the stuff. So this is a system of x prime is equal to x plus 9y, and the second equation y prime is equal to negative 2x minus 5y. They also give initial condition, but we don't have to use it now. You can, when you solve it, you know how to use initial condition to get your C1 and C2 out. So now what we do is we want to plug one equation into another. The fastest and easiest way to deal with that is to locate the single variable. Here is x, right? The others have 9 and negative 2 and negative 5. So if you have one of these that has a coefficient of 1, that's your buddy. So you are going to solve for x, and that x is x prime minus 9y, right? And then you are going to no, you solve for y. Yep. All a nightmare. I know. So either solve for y or solve for x. That's what I was supposed to do. So pick your poison, right? So let's solve for y up there. So that's 9y is equal to x prime minus x, and then y is equal to 1 over 9 x prime minus 1 over 9 x. And then you need y prime to plug in, which is 1 over 9 x double prime minus 1 over 9 x prime. And now you plug both of these in. So this is your y, this is your y prime, and now you have that the y prime is equal to 1 over 9 x double prime minus 1 over 9 x prime is equal to negative 2 x, and then minus 5 times, and instead of y I have 1 over 9 x prime minus 1 over 9 x. So all I did is I plugged everything in. Now I'm going to multiply entire problem by 9 and get x double prime minus x prime is equal to negative 18x, and then minus 5x prime plus 5x. So this 9 is going to kill all of the fraction. Combine everything on the right hand side. X double prime plus 4x prime, and then plus 13x equal to 0 when you move everything to the left. And you have your r squared plus 4r plus 13 equal to 0. And then from here just solve using chapter 2. So you know your r's, and then whatever is repeated, is it complex, is it real, right, so on. So to compress these guys, you can solve for either x in the bottom one, y in the top one, and then just plug in the other equation. Whatever you solve for, plug in the other equation. You have to match the derivative as well. And then just go through the procedure. Now let's take a look at decomposition. All right, so x double prime plus 3x prime plus 7x is equal to t squared. Right, so decompose into a system of first order, right? Yeah.
When you did like those examples, like the one previous one, 4x minus 3y or 6x minus 7y, isn't that the ones that you put into like the 2x2 matrix? You can't do that one?
Not yet. Well, that's going to be third example. So now we want to decompose. The way we decompose is you first set your x1 to be x, and you set your x2 to be x prime. You always start there. Now you differentiate x1 to get x1 prime, and differentiate x2 to get your x2 prime. Now what we need is maybe I can write here in let's say in green, need x1 prime in terms of x1 and x2 only, and need x2 prime in terms of x1 and x2 only. So that's what I need. You need to navigate this mess now. So first of all, right, I have this equation, which is x1 prime equal to everything else, and I have this equation, which is x2 prime equal to everything else. So clearly I'm going to use those two. So if I start by placing x1 prime equals to x prime and x2 prime equals to x double prime, I can't leave it that way because it's not in terms of x1 and x2. So can I make this one, x prime, turn into x1 or x2? And the answer is yes, I can make it to be x2 because of this equation here. And now can I deal with the x double prime? Sure. X double prime is going to be t squared minus 3x prime minus 7x, because that's the differential equation. So now I have x1 prime is equal to x2. We're happy there, right? Just leave it. But then x2 prime still has the x prime and x, but I know what they are. So this is t squared minus 3, and instead of x prime, I have x2, right? Instead of x prime, I have x2, and instead of minus 7x, instead of x, I have x1. So what is the system? The system is x1 prime is equal to x2, and then x2 prime is equal to negative 7x. Well, you can leave it in the upper form, it's fine. Doesn't matter, it's not in so it's good. Right here.
That's the answer right there?
Yeah, it's fine.
I don't remember that.
I'll just solve it with the t squared.
That's what you solve.
Oh, so after that, then they're going to ask solve?
No, decompose. Again stuff. So we are going to jump now into We're going to jump now into our system again, looking at the eigen stuff, 2 by 2, 3 by 3, right? Depending on you know, what I'm inclined to put for the test 3 by 3, what I'm inclined to see on the final 2 by 2, right? The tests are always spicier, but then depending on how long the other problems take, you have an hour for the exam. So, should be okay either way. Operating word, should. You circled 15. That looks like it was a homework problem.
I circled all homework problems.
I'm out of cookies though. x1 prime is equal to 7x1 minus 5x2, and x2 prime is equal to 4x1 plus 3x2. Bueno. So now we get our matrix A as 7, negative 5, 4, and 3. We need to find the determinant of 7 minus lambda, negative 5, 4, 3 minus lambda. So that's going to be 7 minus lambda times 3 minus lambda, and then plus 20, because when you go to the other diagonal it's minus, right? So minus is plus. So this is further equal to 21 minus 10 lambda plus lambda squared plus 20, which is further equal to lambda squared minus 10 lambda, and then plus 41, right? So now we set that equal to 0, and we unleashed quadratic equation upon it. So lambda 1, 2 is equal to negative b, so that's 10 plus minus square root of 100 minus 4ac, so is that 164 divided by 2, which gives me 10 plus minus square root of negative 64, yay, complex, is equal to 10 plus minus 8i over 2. So your two lambda numbers are 5 plus minus 4i. Bueno? Good. So the next order of business is to deal with the lambdas. So lambda 1 is 5 plus 4i. So we plug that into our matrix. So that's going to be, what was our matrix? 7 minus lambda. So 7 minus 5 plus 4i. And then negative 5, 4, negative 5, 4. And then 3 minus 5 plus 4i. And that needs to multiply into vector v1, v2 for the eigenvector to give us 0 on the other end. Oh, we used a and b, right? In class. Okay, here we go, a and b. Don't panic yet. We don't need to panic. All right. So now, when you deal with this, you come up with 7 minus 5. So 7 minus 5 is 2 minus 4i, and then minus 5, and then 4, and then negative 2 minus 4i. Times AB equal to 0, 0, right? And now superimpose a and b on the 2a, so we have 2 minus 4i times a minus 5b is equal to 0. Alright, so that's the equation that we are using. And you can come up with, you set b, let's say, you set b to be 1. So if b is equal to 1, you pick. I mean, you can pick 7.3 if you like paint. Doesn't matter, right? You pick whatever you want for b. And because b is easier here, you will get 2 minus 4i times a is equal to 5, right? So a is equal to 5 divided by 2 minus 4i. Yay, rationalizing, right? So this works out to be 5 times 2 minus 4i divided by, and now when you
have to do the
conjugate, yes, I just froze. So when I do the conjugate here, so I get 4 minus 16, but it's plus 16 because I squared negative 1, and a is equal to 5 and 20 will cancel, so I get 2 plus 4i over 4, so a is equal to 1/2 plus I. So 1/2 plus I.
Why was that 4 plus 16 again?
When you FOIL these guys, right? When you multiply them, it's a minus b times a plus b, right? So you can just square them and subtract them. So we got our first eigenvector, and we have the first eigenpair, right, between the complex number and the eigenvector. So now we rinse and repeat the procedure for the the other eigen, yes.
Do you have to do that though? Because once you do it, it's just going to cancel out and be absorbed by the other C's.
Which one?
C1 and C2. If you do it, you can simplify it in a way that you're not going to be
Wait, for which one? For the second?
Yeah, for the second eigenvector.
Well, yeah, but...
Do you want to do that again?
No, I don't, but it's practice for people that need practice. The reason why I don't need to do any of this stuff. I can just sit home, play Counter-Strike in peace. Like, I don't need any of this. So lambda 2 is 5 minus 4i. And you have... Now, you guys have no idea how quickly I write, so... So I know, and that these are minus signs here. So now I have 7, that's a 2 plus 4i negative 5, and 4, and then negative 2 plus 4i, AB equals to 0, 0. And now it's 2 plus 4i times a minus 5b equal to 0. Let b be 1. So 2 plus 4ai times a is equal to 5. So a is 5 over 2 plus 4i, 2 minus 4i, 2 minus 4i. So Ryan is not complaining. So you have 5 times 2 minus 4i, everything again over 20. So it's a 1/4. I mean, it's 1/4, but then it's 1/2 minus 4i. And That's my 1/2 minus 4i.
Oh,
I put 4? Yeah, just minus I. You're right. It canceled. There we go.
Minus 1?
Yep.
What is it? I just didn't see where the 4 went.
No, there's no 4. I when I cancel it, should just say I. Because this is 5 and 20 cancel, you get 4. 2 over 4 is 1/2, and 4 over 4 is 1. So now we have the second eigenpair, and we can set up the solution. So we have that the lambda 1 is 5 plus 4i with the associated eigenvector 1/2 plus I, and then the lambda 2 is 5 minus 4i with the associated vector 1/2 minus I 1. So now we know that when we have the exponent work this way, right, we can pick x of t, right, to be e to the 5t, and then over here we have a cosine 4t plus I sine 4t, and I need coefficients and I need the vector. Maybe put it in front. Right?
Question.
Yes.
Can you just tell me again why that, explain before, the cosine 4t plus I sine t, that's your A and the B term?
The A term is at 5 and the B term is at 4 is.
4.
Right? You happy?
Yeah.
C2 is going to give us the same deal. So plus C2 1/2 minus I over 1 times e to the 5t times cosine 4t plus I sine 4t. Yes.
Will we just be able to make that on the half?
Yeah. Unless you want initial conditions to make this, to take the derivative and then plug stuff. No? Or just checking. I don't want you leaving disappointed. Thinking I don't care. Well, there is a further calculation that you can do to separate real and imaginary, and you just keep the real part as the answer and you throw imaginary in the garbage. So that's the final step. Bueno? Oh, integrating factor, I almost forgot. Oh, we're not done. there is integrating factor to be had. The what?
Yeah, like how do you, as soon as you see a quick equation of it, integrating factor. dy dx plus 4xy equals 2.
Which one do you say?
Dy over dx plus 4 over x y equals 2.
Equals 2. All right. So integrating factor, I think you use rho of x is going to be what? Anyone?
4 over x. Integral 4 over x.
E to the integral, very good. Function p, which is 4 over x dx. This integral looks not nice. So now this is e to the 4 ln of x, unit plus c. Now this is just x to the 4th.
Because the e takes out that ln x.
Yeah, the 4 will jump. The 4 will jump as the exponent of x, and then ln will annihilate e, and you just have x to the 4th. So now that's the magic number that we have to multiply everywhere. So we have x to the 4th dy dx plus x to the 4th times 4 over xy is equal to 2x to the 4th. So generally you forget x to the 4th on that right side, and that really ruins your day. So now I understand that you can cancel and all of these things, but who cares? Well, actually we can cancel. Maybe you're happier. It's sometimes your happiness is important. 4x cubed y is equal to 2x to the 4th. And now you see that you have a function, the derivative, a function, the derivative. So when you combine all of these things, right, you will use x to the 4th times y prime is equal to 2x to the 4th. At which point you are going to hit both right hand side and the left hand side with the integral. And you will get that x to the 4th y, because the derivative cancels the integral, is on the other side 2 over 5 x to the 5 plus c.
Well, question. Why was the integral just took that out like that?
What integral
The
took out?
integral took out the derivative
Yeah,
dx, right?
yeah, they cancel. Derivative integrals cancel.
Yeah.
So you have the integral of the derivative. Cancel it right away. So y is equal to 2/5 x plus some constant c divided by x to the 4th.
Before you ask, I am disappointed.
Yeah, I know. Some of these things that you don't use for such a long time seems that, oh, integrating factor, but then when you remember it, it's fairly good. See you all, or some of you, on Saturday.